Welcome to This Explainer. Today, we're looking up, way up into the sky to investigate a genuine modern-day mystery. You see, there's this invisible utility we all use, a quiet signal constantly raining down from space that you, me, literally our entire modern world relies on every single second. But recently, well, something or someone has been turning it off.
Let's just dive right into this. The world has never seen this before. That's a direct quote from Professor Todd Humphreys. He's a leading GPS expert at the University of Texas at Austin. His team got a tip to look into some historical data, and what they found was wild, an unprecedented, continental-scale drop in navigation signals. As he said, we have literally never seen anything like this. Receivers across an entire continent were just suddenly overwhelmed. Section 1. A continental GPS mystery. Okay, let's establish our crime scene. Imagine a whole network of GPS monitoring stations spread all across Europe. We're talking way up north to Svalbard, down south to Spain, and as far east as Poland. Suddenly, and completely simultaneously, these stations just went deaf. The signals they rely on completely dropped out, and this wasn't some random one-off glitch. When researchers combed through the data, they found this exact same phenomenon happened 75 distinct times since 2019. This wasn't just static. And what's really fascinating, the data mapped out a very distinct geographic pattern. It looked like the blast center was originating near Kaliningrad. That's a heavily militarized Russian exclave on the Baltic Sea. But hold on, there was a major problem with assuming this was just some ground-based tower. Geometry actually eliminates our usual suspects right away. Because, the Earth is round. The curvature of the Earth physically blocks a ground signal from hitting Spain and Norway at the exact same time. It's impossible. So the source had to be high up in space, at least 1,200 kilometers up. Naturally, you might be thinking, oh, well, it's just the sun, right? Solar storms cause interference all the time. But look at the data here. Solar storms take hundreds of seconds to build up, they affect a massive wide band of frequencies, and they hit the entire sunlit side of the planet. But the actual jamming data, it showed abrupt 3 to 5 second bursts, highly concentrated just over Europe, and strictly confined to a super narrow 5 megahertz slice right where GPS operates. So no way the sun could do this. Only a satellite could.
Section 2. The science of navigation.
Now, before we hunt down the specific satellite, we kind of need to understand the victim here. We need a really quick detour into the sheer magic of how your phone actually knows where you're standing. Because it's amazing. Your phone listens to signals from space. Step 1. The signal tells your phone exactly when it was sent. Your phone calculates the time difference, multiplies it by the speed of light, and boom, it knows its exact distance to that satellite. Step 2. That one satellite puts you somewhere on a giant imaginary sphere. A second satellite narrows that down to a circle where those two spheres intercept. Step 3. A third satellite narrows your location down to just 2 specific points. But your phone doesn't have a multi-million-dollar atomic clock inside it, so its timing is going to be slightly off. So we need step 4. A fourth satellite provides the final piece of the puzzle, the equation needed to correct your phone's clock error. It's basically brilliant geometry playing out right in your pocket in fractions of a second. And this brilliantly illustrates the mind-bending scale of what makes this whole system work. For those satellites to tell you where you are, ground stations first have to tell the satellites exactly where they are. But the Earth's continents are constantly shifting, right? Plate tectonics. So how do the ground stations know their exact coordinates? Get this. They use quasars, massive, incredibly bright celestial objects billions of light years away that act as fixed reference points in the night sky. I mean, think about that. We map the shifting Earth using the distant stars to anchor the very GPS we use to just go find a coffee shop. It's wild. Section 3. Drowning out the signal. So it's this miraculous, math-heavy navigation system. But here is the truly terrifying part. Because it's so complex, it's actually incredibly vulnerable. Take a look at this number, 10 to the negative 16 watts. That is a tenth of a quadrillionth of a watt. When the signal leaves a satellite 20,000 kilometers away, it's basically operating on the power of a standard household light bulb. By the time that signal spreads all the way out and actually reaches your phone down on the street, it is infinitesimally small. It is insanely quiet.
And because the signal is essentially a tiny whisper, it really doesn't take much to drown it out. Jamming is simply broadcasting a stronger signal, essentially yelling, in the exact same protected frequency band. It just completely overwhelms those quiet navigation whispers coming from space. Now, doing this is highly illegal, but someone was doing it with enough power to blanket an entire continent.
The researchers also noticed a pretty spooky clue. Think about it. If this was just a random hardware failure on some old, clunky satellite, it would happen randomly, right? On weekends, in the middle of the night, whenever. But the data showed these interference events were happening primarily on Tuesdays, Wednesdays, and Thursdays, right during standard European business hours. Amplifiers don't just magically decide to fail on a Tuesday at 2 p.m. This proved, without a doubt, deliberate, scheduled, human input.
Section 4. Tracking the true culprit. So we know it's human, we know it's a satellite, and we know it's totally deliberate. It's time to enter the interrogation room and run through the suspects in orbit. Out of about 15,000 active satellites, simple geometry narrowed the list down to just 14 that were visible to all the affected stations at the time. One suspect looked absolutely perfect on paper, an Algerian satellite with a known transmitter operating in the exact right frequency band. But a closer look revealed a completely different reality. The signal-to-noise ratio of that Algerian satellite was dropping at the exact same time, so it wasn't the attacker. It was just another victim getting completely hammered by the real culprit. After that, the trail went kind of cold. Standard receivers only track signal strength about once per second, which is nowhere near enough resolution to trace a lightning-fast 3-second burst. The researchers were stuck behind really frustrating roadblocks for years. Finally, in September 2025, they put out a public plea to the scientific community. And then, a massive breakthrough. By February 2026, they were given raw digitized radio wave data from 2 European stations captured in millions of samples per second. Okay, so the absolutely crucial point is right here. Time difference of arrival. With the raw radio signals from a station in Trondheim, Norway, and another in Amsterdam in the Netherlands, they measured the exact microsecond the jamming signal arrived at each place. Because it hit Trondheim slightly earlier, they could calculate a warped, hyper-precise shape in space, a hyperboloid. Whatever transmitted the signal had to be riding exactly on that mathematical curve, and the margin of error, just 5 meters. Section 5. The Russian Golden Dome.
This changes everything. Armed with this strict mathematical curve, they could test every single satellite in the sky, checking if its known orbit aligned with the jamming data. And the result? The only satellite that stayed perfectly aligned with their data to within 200 meters was Cosmos 2546. This is a Russian satellite, sitting up there in a highly elliptical Molniya orbit. It's part of a constellation of 6 satellites that make up Russia's early missile warning system, often called their Golden Dome. Because of its unique orbit, this military constellation covers massive parts of the globe, meaning it has the capability to jam GPS across regions far, far beyond Europe, definitely including the United States.
Now, as researchers, we have to impartially look at the motives behind this powerful military broadcast. Theory 1. They're periodically testing an electronic warfare weapon. The signal is slightly off the main GPS frequency right now, possibly just to ensure it works without fully disrupting everything, basically keeping the true capability hidden until a hot conflict breaks out. Theory 2. Some scientists suggest these very brief, highly powerful bursts might actually be highly covert communications. By broadcasting near a protected GPS band, they basically ensure adversaries won't try to jam the messages out of fear of breaking their own navigation systems. Both theories are incredibly serious, and frankly, both are completely unprecedented.
Section 6. Fixing a fragile system.
Regardless of the actual motive, these events shine a really harsh spotlight on a very uncomfortable reality. We have built our entire modern society on a profoundly fragile system. I mean, think about what happens if this capability is ever fully deployed in anger. Global satellite navigation underpins everything. It guides massive container ships, commercial aviation. It literally synchronizes the global financial system and keeps cell towers operating on time. It runs the logistics networks that deliver your food, your ride-hailing apps, the whole shebang. It is a vital, invisible infrastructure. And right now, a single system in space has the power to drown it all out. But we do have constructive solutions to survive this. We simply cannot rely entirely on weak whispers from space. Countries need to build out resilient, alternative, backup architectures. This includes using underground fiber optic cables to securely share atomic clock timing. It means reviving things like E-LORAN. Those are massive, high-powered terrestrial radio towers that are incredibly hard to jam. And it means pushing the boundaries of magnetic and quantum positioning tech that doesn't require any external signals at all. We have options. And we need these backups immediately.
Because while jamming simply breaks your GPS by yelling over it, we have an entirely different threat looming on the horizon. What happens when a signal doesn't yell but instead whispers a lie, quietly feeding your plane or your ship a completely fake reality? That's known as spoofing. It is happening to thousands of flights a day as we speak, and it changes the game entirely. But that is a mystery for another explainer. Keep questioning, keep learning, and I will see you next time.